do we consume? This is another MIME type, saying what type of data do we get when the request is made? Well, this is a GET request, and we don't have any parameters, so this isn't consuming anything. I'm going to leave that blank. It'll actually default to text type, but since there's no text coming in, it's not going to do anything. So that's describing the method. And we don't need to describe the response to this method or send back. Now, you could send back one of any number of different response codes. So HTTP has a number of well-defined response codes, one of which is 200. 200 means I made a request to the HTTP server and it came back successfully. So 200 is the OK code. So just to define for this method what happens if everything goes well, you could add in here response details for various error codes like 500 is hello server error or 404 page or resource not found. But I'm just going to go ahead and put in the OK for this method right now. The next parameter of this tag is the data type that's going to be returned. Well, we're returning a JSON array, so I put in SP array. Now, I can choose from a number of different options here. I can send back a straight Boolean piece of data or an integer and so on. So in this case, I'm just sending back an array. So the next primitive format is, if I'm sending back an array, I'm sending back an array of what? I mean, I could just be sending back an integer or a string. So I could choose integer or string or byte or one of the other types. But in this case, what I'm sending back is an array, and it's an array of objects. And because objects aren't actually defined as a primitive type, I'm sending it none. I'm not sending a primitive data type for the return, I'm resetting an object, which is the next parameter. So I'm going to send back an array of objects. But then I need to describe that object. And because this is a single line tag, I don't have anywhere to describe it. So what I'm going to do instead is put in this parameter, which is going to reference a description of an employee object. That means we need to define the employee object. So I'm going to do a little bit of copy pasting here. I'm going to put a constant string, which defines my employee object. I put this anywhere in my code, but I'm just going to put it up here at the top for now. So I'm basically saying this is my employee object, and the properties of that object are, so I have an employee number, and the type of that property is integer, and the first name, which is type string, and so on. So that's describing the objects that I'm sending back. But how do I link it to definitions employee objects? Well, for that, I need another tag. So I'm going to go and get, I'm putting these tags to attributes. Forgive me for the correct terminology there. So this attribute is going to be the endpoint object YAML definitions. So I'm basically saying I'm going to add a definition into the document's definitions section, and the definition that I'm adding is C YAML employee. Well, that's my constant up here, defining employee object. So now my reference to the definition section employee object is complete. So this is the quick documentation for this one method, but unfortunately, if I try to run this module without completing the second method, the YAML document will be incomplete and the server won't start up. So I'm going to go ahead and copy paste in the parameters, or rather the attributes for the get item method as well. So again, we have a request endpoint summary. At this point, we need to get the item data type. Now, this is accepted, the parameter looks like it's being accepted twice. And in the case of simple string, it is. This parameter here is actually here for, as you've seen before, when we pass in an array, we can give the type of object within the array. So I'm just going to go ahead and pass in string. I believe I could pass in none at this point. Yes, not. So I'm just going to pass in string and do the same thing again. And then we're being asked for a schema for the parameter. Well, we're not passing in an object, so we don't need to give it a schema. And we're being asked for a reference to a definition of the object. Again, we're not passing an object, so we don't need to push that in. Okay, and then we come to endpoint response details, and we're doing the same again. We're giving a 200 OK response. We're returning an array. The array doesn't have a primitive format. This should be an object. And we're returning definitions employee object. Now, I don't need to reference employee object again because I've already referenced it here. So that's going to include that into the definition section. So that's both of my methods documented. Let's go and see what that looks like when we explore it using Swagger. So I started up my EMS server with our module in it, and I opened the browser. And I don't really need to go through this PCM, but let's do it one more time. We'll go to API.YAML, gives us the YAML definition. Now if I'm going to do a quick search in here for employee objects, we can see that we're referencing employee object here, and this actually is our employee endpoint get method. This is giving us the summary descriptions. You can see here that we're passing in 3 parameters. Now, these aren't parameters that we set on the method. These are parameters that are sent in the headers by the EMS server. So we can safely ignore these 3 parameters. This method has no parameters going in as far as we're concerned. And then in the responses, we've got our 200 OK, and we're referencing the employee object. If I take a look underneath that, we've got the employee object with an item parameter. And again, we're passing in these 3 header parameters as default for the EMS server. But then we're also passing in on the path, so on the URL here, item, which is to specify the employee number. It is required and it's a string. And then in the responses, we can see again, I'm referencing the employee object. So if I search that employee object one more time, and let's say in our definition, let me take a quick look down here. Okay, it appears it may be missing from our definition, so I'm going to take a quick look at the attributes that we put in here. And I tell you what I think needs to be done. I think I need to move this reference up here onto the class. So I'm going to go ahead and give that a try. Yes, so now I have 3 instances of this. This is my reference. And here is the object itself being pushed into our YAML documents under the definition section. So that's how we can reference definitions and employee object. So now that the document's looking correct, let's go grab it in Swagger UI. So I still have this document open. Let's go ahead and hit Explore again to refresh it. And we can see now that we have an employee endpoint added to our document. So we'll go ahead and take a look inside the employee endpoint here. And I can see that we have one get method. So we're going to take a look under the get method. We actually have an example of what the return record should look like from this method. We have 3 EMS header parameters which we can ignore, and we don't have to put any parameters in. You can see return all employee record being returned from documentation, and so on. So if I go ahead and try this method now, we can see that it is returning all of the data from our endpoint. We've got a response code of 200, and that's our response data. Okay, so let's take a look at the second version, the itemized, and we have employee/item. So I'm going to take a look in here, returns employee record by employee number, and we can see that we have the 3 header parameters for EMS, plus our item, which is required. And I'm going to look for item path again, I'm going to look for item 3 this time, so go ahead and hit try it out. And we can see it didn't get anything back, so there is no employee number 3. Okay, so what time is 5? And here we can see we get Kim Lambert and Kim data come back from the method. Okay, so we've seen how we can add YAML documentation to our custom endpoints, but what about our pinpoints? Well, yesterday we created this EMS pinpoint, which reads data from a joystick and allows us to query that. The truth is we don't actually need to do anything to document our pinpoints. So if we take a look here at the resource that we built yesterday for reading the joystick, we added a lot of runtime type information tags. These are used by the EMS server to generate basic documentation in YAML for our pinpoint. So we go ahead and start up our pinpoint here. I have our EMS development server running in the background. So when we start this up, we're going to go ahead and register and activate this pinpoint. So this is now collecting data from our joystick and making it available to the EMS server. So take a look again in our Swagger UI. I'm going to explore our API again, and I'm going to come under Edge Modules. And we have a get method for getting the Edge modules which are installed. So I'm going to go ahead and run this, and we can see our EMS pinpoint is installed. Okay, so how do we get the joystick data? Well, again, under Edge Modules, we have Edge Modules resources, and we just check to make sure that under the EMS pinpoint, we have a version, API, and most importantly, a joystick resource. So now if we close up the Edge module section and step into the Edge module invokers, we have a get method here, which says get a value from the Edge module by module name and resource name. So we go ahead and come in here, put in our EMS pinpoint module name and joystick, that's our resource name, and try it out. And you can see we've got 2 values come back, the X and Y axis of the joystick, as it currently stands. Let's go ahead and I'll hold the axis of the joystick on one side and we'll try it again and see the different values that we get here. Okay, great. So now we're going to read data from our joystick using a REST endpoint. Let's see how we might build an HTML page which can display the data from our joystick. Okay, so now we have a pinpoint login. Let's consume that pinpoint using a HTML web page. So this is going to be some HTML and some JavaScript. Now, a lot of developers like to use additional frameworks such as AngularJS or Node.js. The Node is actually required. You can use any of the UI, of course, but I will show you that Node is required. You just use plain HTML. So to start with, I'm going to open up the browser. And I'm just going to check that our endpoint is working. I have the EMS server, the pinpoint, and the management console running in the background. So if I go ahead and post in this URL, localhost/80/edge modules, pinpoint, joystick, we can see the X and Y axis data coming back. So it's a simple HTTP call. So I'm going to keep this browser open for a moment, and I'm going to go ahead and create a new directory in the subversion. Just because this is a really great editor with some syntax highlighting, you can use any app to use for this, and then go ahead and pin out to my screen. So I'm going to start by creating a new file, I'll say save as, and let's browse to directly that I want to save this in. So in the subversion you'll find it as a simple HTML client, and I'm going to name this index.html, so it's the page of the website. Okay, so we use some basic HTML here, so I'm going to put in an HTML tag, and type it correctly, and we need a head section, and we we need a body text. Okay. So in the head section, I'm going to go ahead and put in a script tag because we need a little piece of JavaScript, and the tag needs to be closed. So let's start by putting some content into the body. First thing I'm going to put in is just a hello message, and then I'm going to put in some paragraphs. So we'll have paragraph with an ID, and then we'll go for JSON, and close that paragraph off. Let's have another one, ID equals, let's have one for the X input, and close that off. And let's have another one for the Y input. Okay, and then I'm going to need some way to make the JavaScript execute. Now I could do that on a loaded document, but I think I'd rather put this onto a button, so we have an event. So we'll have a button called type button. On click, we're going to have some JavaScript in there that's the button obviously left right. So B and okay, so we go ahead and save that file. So a very basic HTML file there with a couple of paragraph tags and a button. Let's open that up in our browser. And I click clearly, nothing happens. Okay, so we need to script. This user action. So I said something I'll call the user action. Okay, let's create the HTTP file. So I have a var HTTP equals new XML HTTP request. Going from memory, I think that's right. HTTP.open, and we're going to open a URL. I'm going to use the get method because we are calling our REST get method. And then I need to put our URL. So a URL for our endpoint in there. Okay. And then we'll use http.send to execute that call. Now when we get our results back, we need to display them somewhere. So what I'm going to do is use the DOM. I'm going to go for document.get element by ID. Because we named some IDs here, and I'm going to pick out the JSON element there, and then I'm going to set the inner HTML to the XHTTP response text. So we should be able to see what gets sent back. Now, in order for that method to be called, all we need to do is paste a call into the onClick event. So we're now going to call the user action, which should go off and call our endpoint and come back with some data. Let's give that a try. I'll refresh my page over here and click me, and we didn't get anything back, so let me check why that might be. I'm missing a parameter here. And I'm actually missing so we'll set the request header to application JSON. Okay, try that again. And this time together, XML back. So you can see here we have the x-axis parameter and the y-axis parameter from our joystick. So let's go ahead and put those into the x and y input boxes in our HTML. And we can do that just by manipulating the document a little further. So we'll start by getting a response. There's the JSON.parse, and we want to parse the XHTTP response text. So that's going to parse the text that we get back. And then we need to make use of that, so I'm going to go for document get element by ID in HTML again. This time we're going to be modifying the X input, and we're going to be setting that to response.x-axis. Because now we've parsed the JSON object with an x-axis property, and so we can do the same again with the y-axis. So that's that. So go ahead and test this. And we get our x-axis, our y-axis of the JSON packet, and here are the values. So of course we could put some additional text descriptions around this. So let's put x-axis and y-axis. And we'll get rid of the JSON at this point. We don't need to see it, that was there for debug purposes. So let's take that out. And we should put the R in here. Okay, and we can populate our x-axis and our y-axis. So that's how we can call just using plain HTML and JavaScript. Let's take a look now at how we might call this from C#, for example. Okay, so I'm going to build a C# project using Visual Studio. This is Visual Studio 2015. And just to go ahead and start a new project. This is going to be a Visual C# Windows, and I'm going for a Windows Forms application here so we can see a form with our data on it. I'm going to name this Simple C# Project, and I'm saving it into the subfolder directory of the same name, so you can go find that in the source code repository. Okay, so the default project created has a main form, and we've got some components on here. A couple of labels, and I'll have a couple of edit boxes to return our values into, and they're called text box 1 and 2, and I'll have a button to execute the request. Okay, so let's go lay those components out. Let's make these a little longer actually, so they're going to contain some relatively long string values. And then let's go to 1 and 2. Okay, so label 1, I'm going to change the text on this to x-axis, and label 2 to y-axis, and then the button, I'm just going to put the word go on the button. Okay, so now we have a form. I'm going to create an event handler for the go button, which is going to go off and make our REST request. Now, I am by no means a C# expert. I'm actually quite new to C#. or rather I've used it very little. So I'm going to be copy pasting some code in here. And the first thing we need to do is include the using statements that will be implemented with user statements as well. So I'm going to have here system.io, system.net, and system.web.scripts.serialization. So IO is for streams, we're going to be streaming to based upon the web services. .net is for those web services themselves, things we are making web calls. And then system.script serialization is for the JSON deserializing that we're going to do on the JSON data. Now you can see that this library is not identified, we've got a little red line under it, and that's because we need to go out of reference under references. As of .net 4.5, I think, this references to system.web.extensions. Has a different name in older versions of the .NET framework. I think it may have been called system.web.scripts in older versions, that I'm going to need to go and add that into my project. So now that I have that, this little area should go away when we try to build it. I just go away now. Okay, so for the main event handler, I'm going to go ahead and copy paste code, as I said, and here it is. So we have the HTTP web request, which is just a web request component, and it is calling our localhost 8080, edge modules, endpoint, QSC. We're going to make this a GET request, since we're calling the GET method again, and we're going to set the content type to application JSON. After doing this, we get a response class, so we call the request.getResponse to instantiate the response class, and then I'm creating a stream here, which is going to read the response data as a stream, and it will store that data into this string value here, this response string. So then I'm using a JSON serializer to deserialize, so I'm calling the .deserialize method, to deserialize the content of the response string. And this is going into a dynamic object, so this is an object that's going to adapt itself based on the properties that are deserialized. And then I'm simply setting the edit boxes 1 and 2 to the values of the X and Y axes. Then I'm putting off the response reader, and this is all happening within a try catch. If something goes wrong, I'm just setting the text box value to error, particularly useful method for this price for this demonstration. So let's go ahead and save all of that off, and let's see this build. And it does, excellent. So I'm going to go ahead and run this application. And again, with the EMS development server and console and everything running in the background, if I click on go, it's going to go off and make our web request, and it comes back with our joystick data. Okay, so as we're coming to the end of the bootcamp now, I'd like to talk about some of the use cases and reasons why you might want to place logic in your EMS server. Centralization is one reason, of course, but there's also the issue of processing. So if you have a high amount of processing to do, you may not want to run that on a mobile device, which has a limited CPU relative to your server. And one slightly abstract, not really so practical example of this is L system generation. So this is something I started looking at several years ago. And effectively an L system is a mathematical system for rendering natural organic systems. If you want to learn more about L systems or Lindenmayer systems, head on over to the wiki page here. But to give you an example, using an L system, we're able to have the computer draw things like this tree. And I'm going to show an example of something similar to this tree. So effectively the way an L system works is you pass in a starting rule, so in this case it would be the character X, and every time the L system processor finds the character X, it'll replace it with this pattern of X's and X's and pluses and minuses and brackets. And every time it comes across an F, it'll replace it with 2 Fs. And it'll do this in a loop with several iterations. It's actually a recursive iteration system. So what you end up with is a really long string of characters, which you can then run through a turtle program to render as a drawing. So I went down and I found a JavaScript turtle, which was written by a gentleman by the name of Bernie Pope. I couldn't find any license information on this, but as it's published and available, I assume it's good for me to use it. But if you want to find the turtle code, head on over to his blog page here, and if you take a look under software and scroll down, you'll find JS Turtle. So we take a look at JS Turtle, and he gives some examples here. So we can give this turtle some instructions and have it draw things. So let's have it draw forward by say 5 units, whatever 5 units may be, turn right by 25 degrees, and forward another 100 units. So you can see that this turtle is basically just following very simple instructions to render. And if you remember Logo from the 80s, I think it was, you'll be familiar with how a turtle graphic system works. So what I've done is I took the JavaScript and CSS from this turtle, and I created my own turtle client. So go ahead and pop the source code over now. And so what the client does when we call the do Lindenmayer function is it goes out to an endpoint, which I'm going to take a look at in a moment, called Lindenmayer, and it makes a call and has the server do the heavy processing of generating a string of instructions. When that processing is done, we reset the turtle's position, set the color, and then we start looping through the string of instructions that we get back from the server. And for each instruction, we do a different action. So for the F instruction, we draw forward by 4 units. For left and right, we turn the angle of the turtle by 25 degrees. And then we have the ability to push and pop values onto and off of the stack, so we can restore state to a previous state. So that's basically the client side of this application. It's going to render using turtle graphics onto a canvas inside of the HTML page. And of course, we've seen already the REST request being made from JavaScript. So now we're going to take a look at the endpoint that I built for this. It's called EMS Lindenmayer, and you'll find it in the subversion for this session. Inside of the same directory, you'll find the client source code as well. And I've implemented a single method here, so I've got the get method, And what the get method is doing, I'm not actually accepting any parameters. I could accept, for example, the number of iterations, or maybe I could even pass up the rules and the axiom, which is the starting character, but I'm just having no parameters go up, and I'm generating a default system here. And the system that I'm generating is actually that tree that we saw on the wiki page. These are the rules for it, and I set the axon, and then I call my LinMail class, which is also included, and the LinMail class simply runs through and processes strings, and it's going to call the process for each of the strings, and it's going to repeat that several iterations. So I've actually got this default setting to 6 or 7 iterations, 6 iterations here, but you can imagine that, 6 iterations actually on this modern processor isn't going to take too long. If we were to put in 20 or 30 iterations for more complex systems, then that's going to require more processing resource. And in fact, I haven't tried it yet, but I am curious to see how well a ARM processor for a mobile device copes with this code. But for the moment, we're going to run this on our server, and I'm simply going to return a JSON string containing results for us. So that's the results of running the LinMail system. So go ahead and see this working. If I start the application up, it's actually an endpoint inside our EMS development server, and I'm going to go ahead and open this in a browser, and I'm going to browse to the endpoint LinMail. And when I do this, you can see that I get quite a lot of instruction text come back. So that's the heavy processing done. So a fraction of a second actually on this processor, but that's the heavy lifting of the application done right there. And then if I go ahead and open up the example code, the TurboTest code, you can see here my client application. And when I click on the LinMail button, it's going to go off and make that call to the server. It'll get back that string, and it'll process it into Turbo instructions. Now, in order to run this, I need to enable cross-origin. And when I hit the LinMail button, we have a pretty tree flow. Not quite the same tree as in the wiki. I think there might have been actually some confusion about the instructions in the wiki page, that this has been followed literally to the instructions there. So we have a tree rendering. So this is just one example of how you might do the heavy lifting on the back-end server. Now, if we were to extend that out, imagine, for example, you are processing hundreds or thousands or millions of records from a database and trying to get a summation or some other function on that entire data set. What you certainly wouldn't want to do is transfer the entire data. Network traffic, so if this is over a DSL connection, that could lead to quite a high bill. If it's over a Wi-Fi, it's still going to take a very long time. It tends to consume a lot of RAM on the mobile device. And then the mobile processor has to sit there consuming battery, running through all of the data to process the results. I'm not even sure most cell phones today could handle millions of records or even hundreds of thousands. So what we can do is we can produce an instruction on the cell phone, which goes off and calls our endpoint, have our endpoint do all of that processing on the server, and send back the results. The other advantage of this, of course, is if you should need to upgrade the hardware to handle higher data loads, higher processing amounts, then you can, of course, simply upgrade the server that your endpoint is running on, and you don't have to update or upgrade the client hardware. So thank you for entertaining my little LinMail demo there. You'll find that in the subversion repository. Let's take a look at some more use cases. I want to take a moment to discuss what we've learned and to discuss some possible use cases for this technology. I'm sure that you'll have already come up with more interesting use cases of your own, but let's explore just a couple to see what we could possibly do with this. So the first and most obvious is access control. So suppose you have a pantry keypad, and it's being monitored either wirelessly or by Bluetooth or by wire by a pin point. Well, that pin point can forward access requests onto an EMS server, which can then make a decision about whether or not access should be granted, and send a signal back through the same or another pin point to an actuator which controls the door, for example. So what is the advantage of using pin points and distributing this access control setup? Well, the advantage is that you can centralize the access control database. So you could have multiple pin pads and multiple actuators over various Wi-Fi ranges, Bluetooth ranges covering a wide area, possibly even at multiple sites, have them all talking to the same EMS server to make decisions about access control. Another use case might be to use Bluetooth beacons for access control. So to quickly disambiguate, EMS server is the actual server software that exists within RAS server. RAS server is a product bundle which includes the EMS server, and it also includes the Bluetooth beacon sensor. So with beacon sensing, you can track a beacon to within, I think it's an inch of accuracy on indoors. It's kind of like GPS for indoors, where GPS doesn't work too well. Beacons work very, very well down to the inch of accuracy. So you can track a beacon traveling around an office or a factory zone, for example, and make decisions by feeding that data through a pinpoint to a central EMS server about whether or not access should be granted. Another case is the home or office automation. And in fact, one area where we've seen some demand for automation is in the medical industry. So we actually have a nurse's station demo in which a nurse's application is running on a patient's phone. That phone is detected by a proximity beacon, which through a pinpoint communicates to the EMS server, letting the nurse know that the patient has arrived, sending a notification out to their tablet. When the nurse is ready to see the patient, a signal is sent back through the EMS server, which notifies the patient's phone, either by push notification or on the wireless network or some other means. The patient receiving this notification then enters the nurse's office, which means that their phone is again tracked by a Bluetooth beacon through a pinpoint to the EMS server. And once inside the nurse's office, vital statistics such as the patient's weight can be taken on a scale connected by Bluetooth, their heart rate on a heart rate monitor connected by Bluetooth, and all that data is fed back to an EMS server so it can be stored on a central database. let's now take a quick look at this demonstration in action with Jimmy Keith.
This is a brief overview of the Nursing Station demonstration. It all runs on Enterprise Mobility Server backend. The EMS server is running here. It has some existing users already created, but it's easy to create a new one too. The name is test and test, and then your name for the description field. It is really easy to administer. The next step is to run the nurse application, which is on the iPad here. My speaking represents the nurse's room. On the phone is the patient app. It says the patient needs to be in the waiting room to check into the hospital. So the patient goes to the hospital hall. This beacon represents the hospital hall. The app sees it and allows for check-in now. So the patient can sign in. And this sends an EMS push notification to the nurse's application. Now back to the nurse application. It shows that the patient has arrived. This provides his name on the patient list. So the nurse can select the patient when they are ready for them. Here it displays you are now sent in. The nurse is ready to see you, so the patient can go to see the nurse. The nurse application is updated to announce that the patient has entered the room. Now the nurse can provide patient vitals like weight and heart rate via either the keyboard or via a Bluetooth highly connected device like this heart rate monitor. The app just connects to the device, and after a couple seconds of reading, the heart rate is entered automatically. The nurse just approves and saves the data. This is automatically updated on the central computer, which now shows the patient ID, heart rate, and weight. And that's all there is to it.
In large-scale applications, it's important to have technology which scales, and it's important that multiple teams of engineers can work together to produce the solution. With Graph Server, you're able to use Delphi or C++ builder code to provide APIs for web developers or .NET developers to work with, among other languages. You've learned how to share your documentation for your interfaces with other development teams using a common YAML format that can be reused, and how to distribute your IoT devices over wider areas using pinpoints. You've gained an understanding of how to interface with IoT devices from your Delphi applications, and you've even seen that you can prototype and build your own IoT devices. With this knowledge, you can begin to integrate IoT into your own organization or provide IoT solutions for your customers. My name is Craig Chapman. Thank you for watching.
So there was a question for the link to the blog post again, but it's provided that. Also, if you go to the main page, the EMBT.co/IoT Bootcamp 2017, that will link out to everything else as well eventually. So you can find it there. Let's see. Anything you want to add or elaborate on before we get going here?
Yeah, I wanted to sort of come back to a question here actually regarding NoSQL databases or effectively non-relational databases. And in honest truth, I have very little experience with such databases. I tended to always work with relational or index table tabular databases. My understanding, which as I said is limited, is that in a no-relational database, the concern with REST is statelessness, and there are various discussions happening regarding practical applications of REST with non-relational data structures. But there seems to also be something of a misunderstanding that REST is stateless. Now, the primary concept between REST is that the server need not maintain state between two different sessions, but that doesn't mean that there is not state. Typically, the client manages a state, and it is, of course, possible to create state-based resources. So you could have, in things like authentication systems, for example, typically an authentication token is created, and that token sits in a database and can be accessed again by subsequent calls. So it's not like REST completely untold you as state, and I think that's the primary leading concern. The other concern is that relational databases don't tend to send back record sets, so they send back file. In a HTTP setup, that's not an issue. You send back file as a data